All right, let's work with this quadratic algebra from today. So I'm going to show you a couple of these quadratic equations, right? So we're going to solve quadratic equations. Now, a quadratic equation just means there's an x squared in it. There might be some other things, and that's going to be the highest degree term. It's not going to be an x cubed. So that's basically what a quadratic equation is. So there are a lot of looks for these guys. And so one of the looks I gave you today look like this. All right, 3x squared plus, we'll make it 4 equals 100, right? And then another look I gave you, one of the other examples look like this. How about x squared equals 4x plus 77? And then another look that I gave you was this, x squared plus 3x minus 2 equals 0. So these three examples illustrate three different ways of solving these quadratics. Okay. So first of all, note that there are some similarities and differences. The second two are similar in that the second two have, get that out of there, basically three terms. I guess that's a way of writing it, right? There's an x squared term in both of them. There's an x term in both of them, and there's a constant in both of them, right? The first equation has no x to the first term. We call that the linear term, right? The quadratic, the x squared term, and a constant, and another constant are the only terms that we see. We don't see a plus 4x or minus 7x, right? So we approach the first one a little bit differently. So let's talk about how I would approach the first one. So 3x squared plus 4 equals 100, right? I'm just going to use inverses, right, to isolate and chip away at the x, right? So I'm going to subtract 4 from both sides, right? That's the inverse operation of adding 4. All right, I'm going to divide by 3. That's the inverse of multiplying by 3. All right, and now I'm going to take the square root of x squared, which is the inverse of squaring, right? Now when we do that, don't forget there's a plus or minus out front here. And 32, don't forget, is 16 times 2, which, because we're multiplying, we could split up. And then the square root of 16, of course, is 4, and the root 2 stays. Right? So note how I'm just using the inverse over and over, really 3 times. Right? I got to undo the plus 4, so I subtract 4. I got to undo the times 3, so I divide by 3. And then I got to undo the x squared, so I take the square root. All right? Don't forget your plus or minus, because there are two numbers when squared that will be 32. Okay? Now I could do this because there's no linear or quote-unquote, I'll call that really a bx term. Right? There's no plus 7x or minus 8x or plus 1/2 x. There's just a squared term, we call that a quadratic term, a constant, another constant. So for this type of structure, I'm able to just use inverses. For the other two, I'm not, right? Because both contain an x, right? And you guys did a good job factoring this one, but when we factor, you got to set it equal to 0 first. It's not helpful to factor, for the most part, unless it's equal to 0. So let's see how that plans out. Right? So it's x squared, here's a second example, x squared equals 4x plus 77. Now, this one we have truly 3 terms, right? We have a quadratic, an x squared term. We have a linear, a 4x, and we have a constant term. So what we want to do with these is we want to at least start by setting equal to 0 and trying to factor, right? And this one is indeed factorable. I'm going to put an x here and x here. And the two numbers that go in here and here have to multiply to be negative 77. And add to be negative 4, right? So I'm saying, that's going to be negative 11 and plus 7. Okay. Now, because that's equal to 0, if a times b equals 0, that means either a has to be 0 or b has to be 0, right? I have the same thing going on here, right? A times b equals 0. So that means either x plus 7 equals 0, which would make x equals negative 7. That's one solution. Or this factor, x minus 11, has to be 0, which would make x equal to 11. Right? So those are the two solutions that come from my factorable quadratic. Right? The problem with the third one was that, hey, that ain't factorable. Right? X X, okay, there are no two numbers that multiply to be -2 and add to be +3, right? +2 minus 1, no, that's not going to work. So we can't factor, right? But when we can't factor, really there are two ways to do this. You could complete the square, but let's just stick with a quad formula, right? Right, so here's the deal with a quadratic formula, right? As long as we have something that looks like this, ax squared plus bx plus c equals 0. So a is a number. It's really what we call a quadratic coefficient. B is a number. It's what we call the linear coefficient. And c is a number. It's a constant. Then the solutions will look like this. Negative b plus or minus a square root b squared minus 4ac all over 2a. Right? Now a, b, and c are numbers. Right? So if we go back to the problem from today, which is a third example I showed you up there, we're trying to figure out x squared plus 3x minus 2 equals 0. Right? And we're going to use the quadratic formula because we can't factor. And we're not even going to get into completing the square right now, even though that could be a way to solve this. In fact, completing the square is what actually gives us the quadratic formula when you complete the square and solve for x, this general quadratic. But that's neither here nor there. Let's focus on the problem. So it's important to understand what a, b, and c are, right? So a is, really, there's a 1 out here, right? So a is 1. Right? B is what? That's right, it's 3. It's the number in front of the x. And c is close, not 2, but right, -2. Okay? So all I'm going to do is plug those numbers into the quadratic formula, right? So for this quadratic equation, which is equal to 0, with a 1, b 3, and c -2, x will equal -b plus or minus the square root of b squared minus 4a c. Of course, we're multiplying all of those. All over 2a. Okay? That's a multiply here, by the way. So now I just have to work this out. Now understand that this 2 on bottom doesn't tangle with what's underneath the radical. That would violate the order of operation. Right? So I have to simplify everything under that radical. Right? Negative times a negative, there are two negatives, makes a positive, right? So that gives me 9 plus 8, which of course is 17. And that's all over 2. Right? Sometimes we would try to simplify what's under the square root, but there are no square factors of 17. In fact, there are no factors of 17. Right? So what does that mean? It means there are two solutions to that quadratic equation which can't be factored. And one looks like this. I'll call the first solution -3 halves plus root 17 halves. And then the other solution is -3 halves minus root 17 over 2. Right? That's what really that plus or minus means. It gives us two solutions. Okay? Now, I want you to understand how to do these. I'm going to send you some problems to work through tonight, and I want you to do them with intent and purpose. Hope you had a good experience watching this video and doing the problems in the email. Bye-bye.